Okay, so originally I had told you that you have a test tomorrow, but given that we had a snow day on Friday, that got pushed to Thursday. Anyway, then I was out obviously Monday and again today, so we're going to go ahead and review. There is one section that I'm holding off on teaching you. That's the one on word problems, so we won't do number one right now. Just because it's a tougher topic and I want to be here for it. So I'm going to move ahead with the review today, and I should definitely be here tomorrow. That's the plan regardless. So we'll do some word problems tomorrow, and then perhaps the test on Thursday or Friday. So it is coming. I just want to make sure I'm here, obviously, before you do it. So you will not have it tomorrow, although we're doing the review today, because I don't want to get ahead of myself and do the word problems without me here. So we're skipping number one. Number two, and by the way, this chapter is on all the rational stuff. So the rational graphs, the rational writing inverses, the rational and fractional transformations with the graphs, all the skills with adding, subtracting, multiplying, and dividing fractions, and then solving equations with rationals. So this one, when the square of a number is decreased by 9 and then divided by 6 less than twice the same number, the result is, okay? So this is just really Algebra 1, in that it's a description that needs to be changed from English language to math language. So when the square of a number, that's x squared, is decreased by 9, so there it is being decreased by 9, and then divided. So and then means this has to be done first. And then it's divided by, not just divided by 6, it's divided by the quantity 6 less than twice the same number. There's twice the same number and there's 6 less than it. And it wants to know the result. So I would rewrite this in rational form, and you're just simplifying a fraction. Simplifying rational, so it's factor cancel. So we've got the difference of perfect squares and a GCF of 2. And then, of course, the obvious factor that cancels, x minus 3 over x minus 3, leaving x plus 3 divided by 2. So is that 3 more than twice the number? No. 1/3 of? No, it's 1/2 of something, because it's x plus 3 over 2, so it's not 1/3 of something. 1/2 of 3 more than the number. There's 3 more than the number, and then half of it. So it's option 3. Okay, number 3 is a complex fraction, so this is where we look at all the denominators within the fraction, and we have 2 of them, and we multiply by the least common denominator. So these are 2 totally separate factors. So the least common denominator would be x plus y on the top, and x plus y on the bottom. The numerator is a binomial, so I'm going to throw that in parentheses. And when I distribute this to the first fraction, the x plus y cancels with the x plus y here, leaving just 1x. When I distribute to the second fraction, the x and the x cancels, leaving the minus 1, parentheses, x plus y, in that binomial. Our denominator has a y, an x, and an x plus y binomial. So we then simplify that numerator, so that requires distributing. So you've got x minus y all over y, x plus y. Your x minus your x will cancel. So you just have negative y over y, x plus y. And even then your y and your y cancel. So it's just negative 1 over x plus y. Now that answer that I have it in is not there, but the equivalent is, because if I just distributed my x here, I would have x squared plus xy, and that's option 1. Okay, number 4 is something where you would think, okay, if I simplify this quotient, factor cancel, it doesn't factor. And definitely your x's do not cancel. Those of you who want to just cross out your x's and do negative 2 divided by 2 is negative 10 divided by 2 is negative 5. That's absolutely wrong. You can't cross out pieces of polynomials. So this is just really, if you can't factor and cancel, you can go back to your long division stuff. X goes into x once. You multiply that through. X plus 2 times 1 is just x plus 2. Do your subtraction. X minus x is gone. Negative 10 minus 2 is negative 12. And you have no remainder. Or that is your remainder, rather. You can't bring anything down. X doesn't go into negative 12. So you just have minus 12 over your divisor, x plus 2. And the answer there is 2. Okay, on the back side we have an equation that we're solving, and this is just fraction equals fraction, so I can capitalize and cross multiply here, which I'm going to do. Really quickly before I get started though, x can never equal 2. That's an excluded value, and can never equal negative 4. So I'm going to cross multiply. That requires distributing, so 2x times x is 2x squared. 2x times 4 is 8x equals. Cross multiply, distribute with 30x minus 60. It's usually a linear or a quadratic. In this case it's a quadratic, so subtract my 30x over and add my 60. So that's going to give me 2x squared minus 22x plus 60. Now factor or formula, but they're both, every term here is divisible by 2, so I can divide both sides by 2 and by 2. And that's going to leave me with x squared minus 11x plus 30 equals 0. Factor, it's easier now with smaller numbers, x minus 6, x minus 5. So x equals 6, or x equals 5. So which of the following is the smallest solution? 5. That's tricky, of course. They put both the answers there. You have to make sure you read that detail. Okay, so the function is given. Determine the value of the inverse at x equals negative 1, i.e. f inverse equals negative 1. Now, I can write the inverse, and I'm going to do that because I think we need a review of that. So I'm going to switch the x's and the y's. And my goal is to solve for y. I've got them in the numerator and the denominator, so that's the crazy part. Cross multiply. And I have to get all my y terms together, which is tricky because that's in that parenthesis, so I do have to distribute that. And then get all your y's on one side and all your non-y's on another. So I'll bring this y over to the left. And I'll add this x over to the right. So I have 2xy minus y on the left, and then x plus 8 on the right. Now we can't combine the y terms, we're solving for y, so factor out the y. And then divide that 2x minus 1 over, and there's our inverse. So instead of y, we can write f inverse. And they want us to evaluate that at negative 1. So f inverse of negative 1 is negative 1 plus 8, which is 7 over negative 2 minus 1 is negative 3. And certainly I showed how I got my answer. So in the following expression, we want to simplify. So simplifying, again, is always factor cancel. So some of you may be thinking, oh, let's just multiply all this out. No, I want to capitalize on the fact that this numerator is already partially factored. It's almost like mid-grouping. So if you look at the two terms, they have an x plus 5 in common. So I'm going to factor out that x plus 5, and I'm left with a 3x minus 7 minus an x plus 1 over, and my denominator is a typical trinomial. I can factor that into x minus 4, x plus 3. So now this portion I can simplify. So keep my x plus 5, but I have 3x minus x, which is 2x, and then a negative 7 minus a 1, which is a negative 8. So that brings me a step further, and then actually I can factor 2 out of the 2x minus 8. So I put that 2 right out in front. And then my 2x minus 8 becomes x minus 4. And then my x minus 4 and x plus 3 on the bottom. So then your x minus 4's cancel. And there's your final answer, 2 times the x plus 5 over x plus 3. Express the sum below as a single fraction. So this is adding. Adding and subtracting, of course, always needs a common denominator. So this is going to be x plus 4x minus 1. Again, the faster you are at that, the better, because obviously I can get to the point of the problem quicker. This is a GCF one, x plus 4. So they already have the x plus 4 in common. This left side needs an x. The right side needs an x minus 1. So we always multiply out the numerators, not the denominators. So this is going to become x squared minus 6x. And this is going to become, it's a positive 8, so plus 8x minus 8. All over your common denominator. So I've multiplied out the numerators only so that I can then add them. You're not adding the denominators. Once you have your common denominator, you keep your common denominator. So this becomes x squared, these combine, plus 2x minus 8 over x plus 4, x minus 1, and that numerator is not factorable, so nothing else cancels, and this is the sum of those two fractions in simplest terms. Okay, and the last one here, write the following complex fractions. So again, look at the denominators within the fractions. The least common denominator of those three denominators would be 5x. And in the numerator, we've got a binomial we have to distribute, so that will be 10x. And your x's here will cancel. So 10 times 5 is 50. There's my numerator. Denominator, also a binomial. I'll distribute. The 5's will cancel again, leaving x times x, x squared. And here your x's will cancel, leaving minus 5 times 5, which is minus 25. And then see if you can factor cancel. Pull out a 10, left with x plus 5. And on our denominator, we have conjugates. So your final answer is 10 over x minus 5. Now, that definitely did not take the whole class. You still have somewhere around 20, 25 minutes left. So, or should anyway. I'm not going to give you homework on this night other than to start your wheels spinning for studying as far as rationals are concerned. But on Friday with the snow day, you did dodge a spiral. So this spiral you're going to have for homework tonight. And obviously with your 20-25 minutes, you should get started on it. You can feel free to work and ask questions of each other for help, but stay focused. Hopefully you can get these 4 questions done by the time you leave here, and I will send out some answers at some point today from home. If you have any questions, definitely send me a remind message, but I should be here tomorrow.